on trying to, all right. So 1.3, it starts out pretty basic. One word that we're going to see a ton in geometry, if you haven't introduced to it, is congruent. So this word congruent right here. Who can tell me what congruent means? If two things are congruent, what does it mean? Exactly the same. So congruent means that two figures are exactly the same, whether it be two segments, same length, whether it be two triangles, they're the same exact size, same shape, two trapezoids, whatever it is. Two things that are congruent are two things that are exactly the same. And then for congruent, you'll see this symbol. So that's what we'll use to represent congruent. Equals with a squiggly over the top. So geometrically congruent, that's our symbol that we're going to take a look at. So two learning targets that we see in section 1.3 is finding missing measurements of segments using the segment addition postulate, and then also finding segment lengths using the what's called the midpoint. So the midpoint of a segment. So we're going to look at those two things. So I'm going to do number 8. We'll do number 8 together. Actually, we'll do 6 and 7 together because those are pretty basic. And then we'll do number 10 together. So if you want to follow along on your own, you can. Otherwise, you can go back and work on those in a little bit. So first thing is that we'll see in section 3 is the segment addition postulate. I don't want you to get all freaked out about the word postulate. Have you guys even heard of the word postulate before geometry? Heard of postulate before? No, postulate's not a word that we use a lot. But what a postulate is, all it is just a given fact. So it's just something that everybody agrees on that it's true. So there's no, you don't need to prove it. It's just something that's true. Just like two lines that never meet, what do we call two lines that never meet? Parallel. There is always going to be parallel. A straight line is always going to be 180 degrees. So there's no arguing over it. It's just an accepted fact. So postulate, you'll see that fancy word thrown around. All it means is just an accepted fact. It's just something that is always followed in geometry. So at the right there, we're going to use that segment to start working on solving 6, 7, and then eventually we'll get to 8. So what the segment addition postulate says is if you have two smaller segments, a smaller segment A, B, a smaller segment B, C, and if you butt those segments together, they're going to add up to the length of the full segment, AC. So this first problem, if we know AB is 15, now I always think of lumber because I like to do some woodworking things. So if I have a length of a piece of wood that is 15 feet long, and then I butt up against that another piece of wood that's 9 feet long, what am I going to do to figure out the length of the two pieces put together? Add them together. So 15 and 9 are going to make 24. Simple as that. That's the segment addition postulate. It just says if you have two segments, two smaller segments are always going to add up to equal the larger segment when you put them together. Part 2, if you have BC is 15, so just keeping track, this smaller segment is 15. AC is 40, so just a visual, AC all the way from here to here is 40. What's going to be the length of AB? Right there. So if we know the full length is AC is 40, the little piece is 15. What can I do if we got the missing piece? Subtract them. So 40 minus 15, 25. So that length is going to be 25 right there. So that's the segment addition postulate in a nutshell. So it's kind of common sense, but that's what the postulate says, and that's what we can do to start finding the missing lengths of these segments. Now we'll move into number 8. So we start to integrate some algebra into our geometry. Now all of our algebra is just going to be very basic single variable algebra. So a lot of basic algebra. So number 8 says AB is 14. So here's a time where you see AB. Is there a symbol above it? No. So this is representing a measurement. So AB is 14 feet, inches, whatever it is. So AB is 14. The length, the measurement of BC is 2y plus 1, and the length of AC is 5y plus 3. So we're going to find out what is the value of y, and then what is the measurement of BC, and then what is the measurement of AC. So we'll be able to find those two missing pieces. We're going to use algebra to find this unknown. The unknown right now is y, and we'll use the segment addition postulate as well. So just for visualization, now we've got AB is 14. BC is 2y plus 1. And the last piece of information we got is AC is 5y plus 3. Well, similar to before, but now we've got this unknown. We got that y kind of cramping our style in there. We don't know exactly what BC is yet. We don't know what AC is yet. We do know the length of one of those pieces of lumber is going to be 14, but how can we get the rest to work? But based on our knowledge from 6 and 7 and the segment addition postulate, how could I start to compare this 14 and 2y plus 1? How is that going to compare to this 5y plus 3? What am I going to do with those two smaller segments equal to larger segments? Larger segment. Don't worry about the numbers. AB and BC. What am I going to do with the AB and BC to equal the full length of that segment AC? What are we going to do? Add them. So no matter how we're presented, what the lengths of those pieces are, we're still going to stick to that segment addition postulate. We know that the smaller piece, AB, plus that smaller piece, BC, is going to add up to the full length AC. So we now just have to fill in the information we got, which in this case we have some unknowns, but that's fine. We all know algebra, so we can figure that out. So we're going to have 14 plus 2y plus 1 equals 5y plus 3. I'm not going to go through every step, but we can start collecting all the constants. So all the numbers, 14 and 1 on the left side are going to make 15. I would subtract the 3 over. That's going to make 12 on that side. And then the variable parts, we'll combine those together. The 2y is going to subtract over to the right side, which 5 minus 2 is going to give me 3y. So we collect all our constants on one side of our equation. 15 minus 3 gives us 12. We collect all our variables on the other side of the equation. So now we got 3y equals 12. So 3 times something equals 12. That means y is going to equal 4. You guys agree with me on that one? 12 divided by 3, 4. Boom. There we go. So now we got y. Part B, we're going to find the measure of BC, and we're going to find the measure of AC. So no symbols on it means you got to find the measure. So you're going to be given some information where you can figure out the lengths of these, BC and AC. And the key here is we know what 4. We know y is equal to 4. Let's start with BC. So BC was 2y plus 1. Now I know what y is, so I'll insert 4 in for y. 2 times 4 plus 1. You guys get 9 for that one? So BC is going to equal 9. So I'm just taking that 4, inserting it back in for y. There's our result. AC, so now I know I got a 14, and I've got a 9 now over here. So I could take 14 plus 9, it's 23. So let's check, put y in for 5y plus 3. That's going to equal 23. So there would be my two lengths. Right there. For some reason it's not catching up. There we go. So there would be my two lengths, 9 and 23. We don't have inches, feet. We don't have any labels to give it, so we'll just leave it as so. So segment addition postulate, we're going to start seeing those unknowns, those little variables in there. So we have to set up, just knowing that the two smaller segments are always going to add up to the bigger segment, and then we can start to set up an equation. And that's kind of the algebra we'll see right away. So some pretty basics. You guys okay if I delete this one? I'm trying to record a video right now, so then I can go back and get screenshots for you, or you can go back. I'll have that available to you on your Schoology page. So if you ever need it. Okay, let's get rid of that one, and then we'll head down to the second big topic of the day is the midpoint. So down to number 10. So number 9 you'll see is very similar to one we just did. So number 10 for 10 and 11, T is the midpoint of PQ. So we'll find PT in that first one. We'll show our work. We're going to draw another little diagram. So here's P. P is a segment with PQ. And then T is the midpoint. If you watch the lesson video, what does the midpoint do to that segment PQ? I'll give you a hint. Mid stands with middle, so it is right in the middle. And you can't go by my drawing. I didn't draw it exactly in the middle. But if you put a point right in the middle, it's going to split it into two segments. What do you think is going to be true about those two new segments it makes? They're equal. They're congruent. They're exactly the same. So midpoint is a big term that we're going to use, and we're going to start to use it when we start doing proofs and logic. Midpoint is always going to split your segment into two equal pieces. So now we know that PT and TQ are exactly the same. They're going to be equal to each other. What we'll see in geometry is we'll see some more communication things. That's kind of the theme. Once we have a midpoint, we can make tick marks and show that that segment is congruent to that segment. So now we have those two segments are the same because of the midpoint, and we communicate that to people by putting tick marks to show that those two are exactly the same amount of tick marks. That means they're the exact same lengths. Now let's start filling in the things that we know. And things that we know are going to be these two expressions here that represent two of the segments. So we got first PT is 5x plus 3. I'll change color, let's make that stick out a little bit. 5x plus 3 is that piece. And then 7x minus 9 represents the TQ. We may be looking at this and looking at, well, what does PQ equal? We don't know what PQ is equal to. Excuse me, and that's fine. Because we do have something else up our sleeve that we can use. We know that this 5x plus 3 is exactly equal to 7x minus 9. So if they equal each other, guess what we're going to do in an algebra equation? We're going to set them equal to each other. So we're going to take the two unknowns. Anytime we have a midpoint, it's going to make two equal pieces. We'll take those two pieces, set them equal to each other, figure out what is that missing link. What does that x need to be in order to get this length the same as this length over here? We don't know what the lengths are. We know that they have to be the same. So we're going to set them equal to each other. So we'll do a little bit more algebra on problem 10. We'll take 5x plus 3. Set it equal to 7x minus 9. So this is different than the segment addition. Anytime I have two equal pieces, I need to set them equal to each other. Then we'll collect all our constants on the one side. So I'll add 9 over, it makes 12. Subtract the 5x over, it makes 2x. So I'm going to get 12 on the left is equal to 2x, which means x is equal to 6. So we're not quite done yet. That is not the length of PT. So PT represents this expression, 5x plus 3. So to find out what PT is, I'm going to take the x value now. I'm going to put that in. 5 times 6 plus 3. So now I know what x is. 5 times 6 is 30. 30 plus 3. I'm getting 33. How does that sound? Very good. So now I know that's 33. So I know the left side is 33. Since they're congruent, this has to be 33. The whole thing together would have to be 66. So now I can figure out the rest of that diagram. So we'll see two types of situations with our segments. If we're dealing with two unequal segments, we're going to use segment addition to figure out our variable. If we're dealing with a midpoint, two congruent segments, then we can set these two values equal to each other. That's kind of the biggest hang up is when do I set them equal to each other? When do I add them up and set them equal to an expression? So that's kind of the thing that you're going to be working through. But the big thing with midpoint is the middle. It's going to make two equal pieces. It's going to leave you with that type of equation. We're setting those two unknowns equal to each other. So I'm going to leave it at that. I'll leave this up for the hour, so if you want to copy that down at any time, and that can help you move into number 11. So getting to number 11 will be a problem that's exactly the same. So if you want to do that one right away, as we're kind of warmed up now, you can do that. But the rest of the time is yours to kind of work. I will be coming around to help. Later today, I'm planning on putting up a couple of answer keys so that you can check your work. So I've got section 2 done. I'm almost done with section 3. When I get to my prep hour, I'll put those on Swooty so you can kind of check your work over the next few days. Sound good? So you guys are at home some of the time, so it's kind of hard to ask me a question. Hey, did I do this one right? So I'll put answer keys up so you can check to see if you did those problems correctly and you don't get all frustrated.